This video, we're going to talk about 5.2 Objective 3, where we use the 68, 95, 99.7 rule to find percentages and values. So a test of depth perception is designed so that the scores are normally distributed with a mean of 49 and a standard deviation of 8. Use the 68, 95, 99.7 rule to complete parts A through E. Find the percentage less than 49, that would be 50%. Round to one decimal place, so I'll call it 50.0%. Find the percentage of scores less than 57, so that's 50 plus 34 is 84%. Find the percentage of scores greater than 65. So 65 is going to be 2 standard deviations away to the right. So that is going to be this was 13.5, 13.5, and then over here was 0.15 and 0.15, and I had 5 minus 1 is 2.35. So greater than that, though, is going to be 2.5%. Because there's 95% here. And so greater than 65 should be half of that 5% that's left. And find the percentage of scores greater than 41. So 41 should be greater than 1 standard deviation to the left, should be 50 plus 34, should be 84.0. And between 41 and 65, 41 and 65 is over here, 2 standard deviations away. Yes. So that's 68 plus 13.5 is 81.5. Assuming the resting heart rates for a sample of individuals are normally distributed with a mean of 70 and a standard deviation of 15, use the 68, 95, 99.7 rule to find the following quantities. Relative frequency of rates less than 100, so less than 2 standard deviations, should be 5 plus 2.5 is going to be 97.5. This is relative frequency, so it's not a percentage. So 9750, 0.975. They want 3 decimal places. Greater than 85, so more than 1 standard deviation to the right is going to be 50 minus 34 is going to be 16%. And then between 40 and 70, So 40 is 2 standard deviations to the left. And so that is going to be 47.5%. Like that. And again, I'm just using these percentages that are here, but I'm changing them to decimals and I'm adding those pieces parts together. So 100 was going to be 2 standard deviations to the right, which is here, and then just add all those pieces together. There's 50% plus 34% plus 13.5% is 97.5% right there. 85 was, and we wanted greater than 85, so 85 was here. Greater than 85 was 13.5, 2.35, 0.15 is 6, 9, 10, 16.0%. So that's 16% right there. And then we have this last one was between 40 and 70. 40 was 2 standard deviations to the left. 70 was right in the middle. So it was 34 plus 13.5 is 47.5%. And that's it. Let's go ahead and in the study of facial behavior, people in a control group are timed for eye contact in a 5-minute period. Their times are normally distributed with a mean of 176.0 seconds and a standard deviation of 51.0 seconds. So let's make our chart here. 176, I won't put the decimal points here. And then 176 plus 51 is 227, plus another 51 is 278, plus another 51 is 329. Then I'm going to go 1 to the left. It's going to be minus 51 from this is 125. Minus another 51 is going to be 74. And then minus another 51 over here is going to be 23. And that represents my plus or minus 3 standard deviations. Find the percentage of times within 51 seconds of the mean. So when they say within 51 seconds, they mean plus or minus 1 standard deviation. So that's going to be 68%. Find the percentage of times within 102 seconds. So that's 2 standard deviations. That's going to be 95%. And then within 153 seconds, which is 3 standard deviations, is going to be 99.7%. And then we can put 1 decimal place here if we want to, since it says round to 1 decimal place. Find the percentage of times between 176 and 278. So that's from 0 standard deviations to 2 standard deviations to the right. So that's going to be half of my 95 is going to be 47.5. I could also get that with my 34 plus my 13.5 0.5 would also give me 47.5, two different ways to get that. And that's it. Let's go on to the next problem. Consider the table showing the official mean weight and estimated standard deviation for 5 US coins, and suppose a vending machine is designated to reject all coins with weights more than one standard deviation above or below the mean. So we're going to, this is why I have the calculator out here. So we're going to take 2.500 and we're going to add 0.08 to that to get 2.58 for my upper limit here. And we're going to take that and subtract to get my lower limit of 2.42. Now I'm going to do that, and I'm going to have 5.000 plus 0.07, and we're told to round to 3 decimal places here, so this is going to be 5.070. We're going to switch this to subtraction here, and I get 4.930. Now let's look at the dimes. 2.268 plus 0.03 is 2.298, and we'll switch this to subtraction. We'll get 2.238, and now let's look at the quarters. 5.670 plus 0.05 is 5.720, and switch that to subtraction now. It's going to be 5.620. And then we're going to look at half dollars. Is 11.470, and we'll switch that to subtraction, and we get 11.210. In each case, what percentage of legal coins are rejected by the machine? So it's going to take 68%. So 100% minus 68% is going to be 32% of the coins will be rejected. That's pretty high, all right? So I believe that's it. Yes, it is. So we will come back next time and talk about 5.2 Objective 4. See you for the next video.